Namaste everyone. In this video we shall answer a question related to Ohm's law. So in this question they say there is a person by name Amita. She had connected a circuit as shown in figure A, and here in figure B they have shown the readings of ammeter and voltmeter. So based on these readings we need to determine or find the value of resistance R. So let's see how we can find the value of resistance R based on the ammeter reading and the voltmeter reading. If you look at the ammeter reading carefully, here it is 0, here it is 0.5. So what does each division correspond to? Each division will correspond to 0.5 minus 0 by 5. Y divided by 5? Between 0 and 0.5 there are 5 divisions here, 1, 2, 3, 4, 5. So that's why I'm dividing by 5, and this is 0.5 and this is 0. That's why 0.5 minus 0 divided by 5. So this will be 0.5 by 5. So each division will correspond to 0.1 amperes. Each division will correspond to 0.1 amperes. Now this is 0, this is 0.1, this is 0.2, this is 0.3, 0.4, 0.5, like that. Anyways, here the pointer is pointing to this, which is nothing but 0.1, 0.2, 0.3. So the ammeter reading is 0.3 amperes. So the ammeter reading and you know the ammeter reads current, so ammeter reading is 0.3 amperes. Now let's look at the voltmeter reading here. Now here what is the value of each division, or what is the value of one division? So here 0, there is 1, so it's what is the value of each division? So it's 1 minus 0 divided by, there are 5 divisions, 1, 2, 3, 4, 5 divisions between 1 and 0. So each division will correspond to 1 by 5, which is nothing but 0.2 volts. Each division will correspond to 0.2 volts. Now 0.2, 0.4, 0.6, this is 0.8. You have to increase by 0.2 with every division. So the needle is pointing to this, which is nothing but 0.8. Once again I'll tell you, it is 0.2, 0.4, 0.6, 0.8. So voltmeter reading, and we know the voltmeter reads potential difference or voltage across a resistor or across a device. So how much is that? It is equal to 0.8 volts. Now how do we find the resistance? We need to find the resistance. In the first sub question, find the value of resistance R. In the sub question A, we need to find the value of resistance R. So by Ohm's law we can write V is equal to IR. From this I can write R is equal to V by I. So R is equal to V value is 0.8, 0.3. So this, if you multiply numerator and denominator by 10, this will be 8 by 3. So this will be 2.66. It continues like that. We can round off and say the resistance is 2.67 ohms. What is the resistance? It is 2.67 ohms. So this is the resistance of the resistor. We have found the value of the resistance of the resistor used in the circuit by ammeter. And what is its value? It is 2.67 ohms. Okay. Now let's see what is question B and how to answer it. Amita forgot to put a switch in the circuit. You can see that there is no switch in the circuit. You all know that the symbol for a switch is this is open switch and this is close switch. You don't see this particular symbol being used in the circuit. That means she has forgotten to place a switch in the circuit. So now, so what happens? That means the current was flowing through the circuit during the experiment. during the experiment. So, and you know that as current flows through a resistor, it will produce some amount of heat. That's why what happened during the experiment, the resistor became hot. Whenever current flows through a resistor, heat will be produced. This we have learnt as heating effects of electric current. So it has become hot, means its temperature has risen. But here, what does Ohm's law state? The Ohm's law statement, I am writing the statement of Ohm's law. It says that the potential difference across the ends of a given metallic wire is directly proportional to the current, provided its temperature remains the same. So V is proportional to I, provided temperature of the resistor is same. But here, is the temperature same? No, the temperature is not same, because the ammeter has forgotten to place a switch in the circuit, and consequently current has been constantly flowing through the resistor, and we know that current flowing through a resistor will produce heat. Because of the heat produced in the resistor, the resistor has become hot. In other words, its temperature is risen, its temperature is increased, temperature is not same. Anyways, now what are we supposed to do now? We are supposed to draw two potential difference versus current graphs on the same diagram as expected by Amita based on the actual observation she would make. So Amita is she's verifying Ohm's law. She knows that V is proportional to I when temperature is same. In other words, so when she plots a graph like this, like let's take the current values on x-axis and the potential difference values on y-axis. So she is expecting that potential difference is directly proportional to current and the temperature is constant, and consequently what we'll get is we'll get a linear graph. That is a graph, it's a linear graph. Okay, this is linear graph, and its slope is constant with constant slope. Now we know that the slope of VI graph gives us resistance. So the resistance is constant here. Resistance is constant. This graph is as expected by Amita. But because of her mistake, the mistake of not placing the switch in the circuit, we know that temperature has increased, and we also know that resistance of a metallic wire is directly proportional, R is directly proportional to temperature. R is directly proportional to temperature. So if temperature rises, resistance also will rise. That means the graph which she would get based on the actual observations made by her would not be a graph with constant slope. So it will be a graph which looks like this, somewhat like this. So this is the graph, which is the VI graph as per or based on actual observations. So we have plotted two potential difference versus current graphs on the same diagram, and here let's speak something more about this graph too. Now we know that slope of the VI graph will give us resistance. So if you find the slope by considering any 2 points on this graph, you will get a constant slope, indicating that the resistance is constant. Resistance will remain constant as long as temperature remains same. But here the temperature has increased, the resistor has become hot. So what happens? Resistance will not remain constant. In other words, the slope of the graph will not remain constant, whereas the slope will be increasing. The slope of the graph will increase. Why? Because the resistance also will increase, if the temperature rises. We know that resistance of a metallic wire is directly proportional to temperature. So they had asked us to draw two potential difference versus graph on the same diagram as expected by Amita. This is the graph as expected by Amita, which is indicated by 1. This is the graph based on the actual observations made by Amita. So this is graph 2. I hope you have understood this explanation. Thank you for watching. Please subscribe, like and share. Thank you again.